What's up? In this tutorial, we are going to cover how to create random assets using PCG assemblies inside of a blueprint. You can see my example here. I have a bunch of barrels with weapons inside of them, and every time I place them into my world or move them, I will get a new random assortment of weapons that are choosing from a random array of weapon options that we can predefine, or random number that we can predefine, and randomly scaling and rotating them a little bit and putting them in the barrel. And then the barrel as well, it has a random color assigned to it. So lots of options for randomization. And the way that we do this is through PCG assemblies inside of a blueprint. So it's a super efficient method for spawning meshes because they're all instance meshes inside of our blueprint. It's a great way to just add a lot of randomness, and this could be used to create either structures or natural assets like clumps of foliage and or cliffs or things like that. It's just a really adaptable method of asset randomization. All right, let's get into the tutorial. First step here is I will just jump into an empty level here that's a little more easy to look at. When we start here, we want to create a PCG assembly, which will be kind of the blueprint or the instructions for how this asset or prop should look. I have a collection of meshes here, and I have a few starting weapons here, and this is basically like where I want generally the weapons to be inside the barrel, and later on we'll go and replace those with random options. But this is kind of my starting point. I want to create like basically one perfect asset that I'll then go ahead and add randomness to. So I've gone ahead and I've created this barrel. Now I need to go ahead and collapse this collection of meshes into a sub-level so that we can export that into a PCG assembly. So I'll go ahead and grab all of these meshes, and we will go ahead and right click on them in the outliner here, choose the level and create level instance. This will take those meshes, collapse them into their own sub-level inside of our main level here. So we'll go ahead and hit that, and it will ask us where we want our, our Z to be, our origin point. Usually I will leave this the same, but you have a few options here, and we'll go ahead and hit OK, and it'll ask us to save our level somewhere. So I will call this PL for packed level _ barrel, weapon barrel maybe. So now you can see we have a sub-level here that we can move around that has all of our meshes inside of it. This is how we go ahead and export a PCG assembly. We create a sub-level and we right-click on that sub-level. If I go and look for it in my content browser, I right-click on it, come to Asset Actions here, and we choose Create PCG Asset from Level. Now, before I do this, I want to tag my object. This is how we add randomization to a PCG assembly later. What an assembly is basically doing is it's taking a bunch of meshes, in this case, our barrel meshes and our weapon meshes, baking that into point data. It's taking it and saying, at this point in space, there's an object, and it's saving that into a point, and that point has the data on that point for what mesh it should be later on. So it's a very efficient asset. We're just stripping out the meshes and just leaving their path basically. And on each point knows what mesh they should be later. And so what we can also do is add a tag onto those points so that we can do modifications to those points before we actually spawn the meshes back on them. And that's how we add randomness into an assembly. And this is all going to make sense in a moment. So, okay, so let's go ahead and add those tags. So I just will add two simple tags in this example, and to go ahead and edit a level, a sub-level that we just made, we can either double click on this to open it in its own level, or if we go ahead and hit this edit button here with our sub-level selected, we can go ahead and modify it and move our objects around, and then that will go ahead and save into that level. So it's a nice way to go and edit a bunch of sub-levels in your main level. So we'll go ahead and select our weapons here. I will go ahead and add a tag. Now I could scroll down here to the actor tag section, or I could type in the search bar here, just tag. And what we want to do is add an actor tag, not a component tag, an actor tag. So we come under actor, under tag, and we will just call this weapon. And then we will go and click on the barrel, and the barrel will go and add a tag as well. We'll call this barrel. And you can imagine if you were doing this to a house or a rock with a bunch of grass and trees on top of it, like a clump of assets like that, you could add individual like tags that would tell you things you could do later, like random scale, random rotation, or this is a rock, this is grass, this is a tree. And that's totally up to you how you want to kind of divide your data to use later. And for me, it's just simple example here. So I'm just doing weapons and barrels, but we could do any number of tags on these objects, and that would give us all the kind of sorting that we need later in our PCG graph. Okay, so I'll go ahead and I'll hit save. And now we have our level, and now we can go ahead and right click on it, asset actions, and create PCG asset from level. And this will let us create a PCG assembly, which is, like I said, going to take all of these meshes, bake them down into points. I'll just let it use its standard name here, which is just the name of the packed level here. We'll go ahead and hit save, and there we go. Now we have a new packed level with the weapon barrel name assigned to it. Okay, so now let's create our blueprint and our PCG graph to go ahead and read this data into it. I'll come over to my blueprints folder, and I'll right click and I'll create a new blueprint class. And we'll choose an actor option, and I'll choose BP underscore, and we will call this weapon barrel. I'll double click on that to open it. I'll move it over here. And we'll also go ahead and come to my PCG folder, and we'll make a new PCG graph called PCG underscore weapon barrel. And in my blueprint here, I will go and add a PCG component. And in that PCG component here, it has an input for our graph. So I'll go ahead and drag my new graph in here to the blueprint. So now we'll go ahead and hit compile and save, and we'll open up that PCG blueprint as well. Now that I have my PCG graph open, I'm going to come back to where I saved my PCG data asset. So remember, this is the points that are baked from the meshes. So now I'll drag that into my PCG graph, and it will automatically create me a load PCG data node, which is loading this assembly, PCG assembly asset. Now the way this works is that this is a bunch of points, right? This is a PCG collection of points. All we need to do is use a copy points node to basically attach that to any number of other PCG points. Then it will go ahead and spawn in those corresponding locations. So you can imagine if we wanted to spread these barrels infinitely across our landscape, we would just grab some landscape data and use a copy points node to connect it to those points. But for us, we want to use this as a single asset that we can place into our world. And so we're going to be using the origin point of our blueprint as the starting point for these PCG assets to spawn. We use a get actor data node here, and it's getting itself by default, which is great, which is us. So we're a PCG graph inside of a blueprint. So we're getting ourself, basically our origin point. And so that's a single PCG point. If we go ahead and under the mode here, switch it to get single point. So now we have a single point. Now we need to attach our PCG data asset to each of those points. In this case, it's just one point. So we'll go ahead and right click and choose copy points. And of course, the target is our get actor data node, and the source is the points coming out of our PCG assembly. This root point is like the origin point of the assembly, which, you know, in some cases used for certain effects, but all I need is the points here and the copy points node as well. If I go ahead and I hit save and I drag this blueprint, if I go and look for it, and I drag this blueprint, not my PCG graph, the blueprint, I drag the blueprint in here. Obviously, we're not going to see anything because this is just attaching the points, right? It's not spawning any meshes yet. But if we press D, we can see the points are indeed coming through, and they're just coming in as little cubes at each location that the weapon and the barrel should be. Now we can go ahead and add a spawn mesh here, static mesh spawner. In the static mesh spawner, normally we would put a bunch of meshes, right? We would come in here and under the mesh entries, we'd add multiple mesh entries. But in our case, what we want to do is literally just come over and switch it from PCG mesh selector weighted. That's what it's talking about. It's talking about adding a bunch of mesh entries here and weighting them. That's how we would normally do it. Now we're going to switch it to from that to by attribute. So now it's looking for an attribute on the point to get the mesh for it to spawn. And we just need to tell it now the attribute name that we get. And if you always want to check this, you can come over to my points and choose A, or type A rather. And if we expand our point data here, so if we come over here to the mesh area and we expand that, we can see this has all of our, our meshes plugged in and attached to each point. And if we scroll to the right here, we also have our tags that we added right here, weapon and barrel, which we're going to use in a minute. So we can see here that the attribute that contains the data on each point is called mesh. And so all we have to do is type in that attribute name here and it will go ahead and look for that mesh and spawn that mesh. And we can see it successfully did that. So now we have a blueprint with a PCG graph inside of it, taking an assembly that we've baked from a level and then reconstituting it into meshes. But now that we've done this, we can go ahead and do some fun things with these points, because now we have each of those objects as point data, right? So before we spawn our meshes, we could go ahead and start doing some fun things to them. First thing I want to do here is actually go ahead and filter out the different types of objects. So now it comes back to that moment where we went and we added tags onto each object. Now we can see that those are coming through here as tags. Here at the end, we're seeing weapon and barrel, and these are tags that are booleans basically. So is it a barrel? Is it a weapon? And so now we can filter those points. So if I disconnect here by holding down Alt and clicking, and we go and drag off of this and create an attribute filter, now we can go ahead and choose in the attribute filter equals, because we're looking for something that equals. And the attribute type here is going to be the name. So is it a weapon? And it's a constant threshold, which means instead of looking for an input for the attribute that we are trying to adjust, we're going to literally enter it right here, which is a Boolean. So we're saying, look for this attribute here. That's the specific type of data, Boolean. And the Boolean value should be yes, on. So it is indeed a weapon. And so everything inside this filter should be a weapon. So let's test that. If we drag off of this, this should spawn only our weapons. Okay, great. So it's spawning our weapons here, and our barrel here is going to spawn something else. Okay, so we can copy and paste our meshes spawner here, or we can literally drag them both into this mesh spawner here. So now we divided this out. So let's go ahead and add some randomness to the weapons. So we'll go ahead and drag off of the inside filter and make a transform points node. And this transform points node, let's go ahead and add random rotation. So now all of the objects are going to be randomly rotated around in their Z axes, and the axis is the local axes of the object. So you can see that the meshes here, they still point, in the general direction. But since we're rotating Z, they're just going to be spinning around like this. If this was grass, for example, the grass could still be locked to the surface, but you could add random rotation in the up axes. Unless, of course, we turn on absolute rotation. Now we've added some random rotation. Let's add some random scale. So they could be between 0.8 and 1.2 maybe. We don't want to break this too much. Now they also have a random scale. So this is pretty great. Like, we have a blueprint now, and each time we move it, the weapons will again randomly spawn here. Now, if we wanted to choose a random selection of weapons, for example, or rather we wanted to spawn a random number. So we want to say these are the most amount of weapons that could spawn, but we want to spawn about 50% of these weapons each time. We could use a select points here in between. So I could connect this up in between, and in the select points, I could choose a ratio. So like 0.5. So now about 0.5 of the weapons will show up every single time. So this is another possible way to add randomness. We can use a random choice node, which would let us choose an exact number of points here. So if we want to choose one weapon each time or two weapons each time, we could go ahead and enter that in here. And this could be a variable. We could drive this from a variable through our blueprint. So if we come over here to our main blueprint and we add a new variable, and this could be a integer. So it's not going to have any decimal values, just going to be an integer. And we could call this number of weapons, and we could turn this on, and let's make it default 8, compile and save. Then we could come here and type in get actor property, and this will let us get a property parameter from our blueprint, our parent blueprint, and drive this node, this PCG graph from that. So we'll go and we'll type the property name we're looking for, which is number of weapons. So we'll go ahead and make the property name number of weapons. And if we've successfully typed it in, the error will go away here, and now we have an attribute connected to our blueprint up here. If we go ahead and expand our random choice and choose the fixed number input, which corresponds to this fixed number here, and we plug that in and we hit save. Now in our blueprint and our level, if we go ahead and select it, we now have a number of weapons control. So now we can go ahead and reduce this and adjust it to the number of weapons we'd like to see at any one time. Hey, just wanted to jump in here and say that if you are getting a lot out of this tutorial and you are tired of endlessly scrolling YouTube and piecing together information from different tutorials to help you learn PCG topics or environment art topics in general, like materials and level design, all that good stuff, then you might be interested in Asial Arts Academy. It's my full package of resources that include both access to all my asynchronous courses, but also I go in, I jump in, I work directly with you. I create training material and video tutorials directly on your questions, on the things that you're working on, and you get access to a private group of other environment artists going through the same journey as you. We also do regular live calls where I teach demos and answer questions and things like that. I even have some super special tools, PCG tools, and things that I only give to members of the Academy, which will really supercharge your creative projects and save you a lot of time. You can check out some of the 5-star reviews of other students that have gotten a lot out of it. It was really helpful for them in their journey in learning PCG and Unreal Engine. If this sounds like something that you would find helpful, go to the link in the description and take a look. All right, let's get back to the tutorial. But I'd like to take this a step further because this blueprint is spawning a random number of weapons, but I'd like to also have an option here to add new weapon meshes in and basically take these starting weapon positions and just cycle through even more options, even more weapon options. And so what we can do is we can make a parameter in our blueprint here for meshes, an array of meshes, and then randomly replace those weapon points with meshes from our input. We're going to come here and make a new variable, and this will be mesh, static mesh. And we'll come and find static mesh and choose object reference. Under the settings here, we will call this weapon meshes, and we'll go and we'll switch it from a single object type to an array. And we'll also turn on the eyeball here in the left corner so that we can see it outside of our blueprint. So we can see now that when our barrel is added to our level, we have an array here and we can add new weapon meshes in here. And so let's go ahead and add a bunch of weapon meshes in to this. So if I come over and come to my meshes area here and I type in weapons, I'll search my weapon meshes, and I'll come here and I'll grab all the spear-like weapon objects and I'll drag them on top of the array here to add them all in. And now these are all my possible options for weapons. So now I just need to read these new mesh options in and randomly assign them to points in my PCG graph. So we'll come back here, we'll come back to our PCG graph, and we'll choose a new get actor property node, and we'll come here. And this can be before or after my transform points node, doesn't matter. So I'll come over here. And now the way we randomly assign data to point values, so we have a collection of points and a collection of data, the node that we use to just randomly sort it onto different points is called a match and set node. So if we type in match and set attributes, and we plug in our attribute to match and set, and then we plug our attribute in here. Now, if we go ahead and we press A to look at this data, we're not getting anything because we didn't connect our get actor property. So we have to come back here and look at the name. So it's weapon meshes. I'll come back to my get actor property, type in weapon meshes. And now we have a new soft object path to a new set of meshes. So if I go ahead and expand this, we can see this is our new randomly assigned meshes. So we're basically taking the stream of points, and the value that each point has is called mesh, and it's a certain weapon. And so we're adding new data in here into the stream, and it's going in its own value. So what we want these new meshes to come in and just replace the old meshes that are on the point. So the way we do that is we come to our get actor property node here, and right here where it says output name. So this is taking a bunch of attributes, and we can say, take this collection of meshes and save it into the mesh attribute, which you can remember from our PCG points here is what's getting picked up from our static mesh spawner here at the end. That's called mesh, this attribute name. That's where all our points are saved, their meshes. So we can say, take this new random array of meshes and save them into the attribute name mesh. So we'll go ahead and type that mesh. All right. Now, if we come back here, we can see that all of those random barrel meshes have been now replaced by a completely new set of meshes that are getting read from my array of meshes over here. So it's taking those meshes, it's replacing, kind of hijacking the original points mesh connection and just replacing it with these new meshes. But since we've, hand placed all of those weapons originally, they're showing up in like places that weapons should show up in. So now we can just have random weapons every time we place it. So this is great. One final step here would be to add some random color. This is actually done through the material on the material level because these points are instances. So each new mesh is a hierarchical static mesh. mesh, so it's an instance of a mesh, we can actually leverage that inside the material to add some randomness to the object. We can say for each time there's a new instance of this object, do something, choose a random thing. Okay, so we need to just go into the material for the barrel here and replace it with a material that allows for that kind of logic. So for this, we need to go back to our original mesh barrel. So this original mesh barrel, if we go to our level and we choose edit, and we take this mesh and we go and we come to where that material is saved, what we want to do is make a new master material for this mesh because we're going to need to change some logic. So I will go and open the material instance that we have here, and we will go to the master material and open that up. And so this is what the master material for this mesh happens to look like. And so we just need to come in here and do some adjustments. But first, I probably want to duplicate this material. This material is a master material that's reused over a lot of different meshes in my level. And so if I want this randomness to just be on the barrel, I should probably duplicate this master material to make before I make any adjustments. So I'm going to come over and look for where this material is, right click on it and duplicate it, close that material. And what we need to do is come over to this original static mesh that we were using and apply our new material to it. So in the level here, I'll click on the static mesh and I'll actually open up the original mesh reference, because this won't realize when it, when it spawns the mesh from points, it's looking at a content browser path to the mesh. And so it doesn't actually know that if we've added new materials to it. It's not smart enough to know if we've added a new material to it in our level here, that it should be a new material. It's going to take whatever material is assigned to the original static mesh in your content browser when we respawn the barrel. So we need to actually go in a little deeper and change that original material. So if I come and I double click on that mesh to open it, we can see this is the original material assigned. And so I just need to come in here and add this new material, either a master material or a material instance, either one. Okay, so now I go ahead and save that mesh. And now if I double click on that new master material, let's go ahead and add our new logic in here. So I'm going to add a variation in color. This could work on anything in your material, but what we're going to do is just tint the color, 3 different options of tint based on a random value. So the random value we will get is called per instance random. And per instance random is going to, like I said, look at each random instance of a mesh and then choose a random value for it. And so we can take that and we can plug it into something. So what I'm going to use to tint this is called a 3-color lerp. So if I go ahead and type in, actually, so lerp 3 color. So we choose lerp 3 color here. Now we can plug 3 colors in here and randomly blend between them based on an input. You might be familiar with a standard lerp, which is between 2 colors. This, or 2 values. This is a lerp between 3, in this case, vector values based on an alpha. So if we plug our per instance random into the alpha, we are going to randomly blend between these 3 inputs based on this per instance random. So this gives us a great opportunity to do some color variation. So we can choose 3 colors in this case. So I'll go ahead and hold down 3 and click to make a slightly maybe redder option. And then I'll copy and paste that to make a slightly bluer option, and copy and paste it to make a slightly greener option. So now we have a red, green, and blue tint, and we can always come back here and adjust them when we see how it looks on our barrel. So those are our 3 tints. So we'll go ahead and plug those into the 3 inputs in the 3-color lerp. And now we just need to create a multiply node by holding down M and clicking, and multiply that over the original base color in our material. So now we have our tints controlled by a random per instance value blending between these 3 colors, and we're multiplying that on our existing color value. So now if we go ahead and hit save, and we go and save on our original level here, we come back over to our blueprint, because you'll see it's not going to show up on our nested level here because these aren't instance meshes. These are our starting meshes. But if we come back over to our blueprint now that's using instance PCG meshes, now every time we move this, it's going to give a slightly different tint to the barrel and slightly different weapons. And if we wanted the tint to be more intense, we could come in here and make these colors a little more obvious, because the richer the color, the more they're going to have an effect on the tint of the base color. So now if we go ahead and we change this, we're going to get much more of a drastic tint value here on the barrel. And like I said, this blueprint has all these static meshes here that every time we move it, it will give a random value. But if we want these to auto-populate as we place it into our world, which is the example I gave at the beginning, all we need to do is come back to our original blueprint here and open it up. And in our weapon meshes array here, we just need to grab these weapon meshes and, use them as our default values, because, on default, when we drag it to our world, it's just going to be empty because we haven't added any meshes to it. So if we want it to do that automatically, our last step here could be to come and grab our weapon meshes and go ahead and shift drag over them and add them as the default values for the blueprint. So not something we change in our level, but in the blueprint. Then we could go ahead and come back to this blueprint. And now every time we add it to our level, it's going to add a new collection of weapons. And there we go. That's how to create a random asset, placeable asset using PCG assemblies. This can be applied in a lot of different situations. Obviously, you could apply this to natural rock formations and clumps of foliage assets and things like that. But you could also apply this to, like I said, structures or a table full of food or piles of trash like vehicles, whatever it is that you need to be randomized, and you want to use these, the efficient hierarchical static meshes that PCG can allow for. This is a great way to set that up. All right, I hope you found this video helpful. If you did, let me know with a thumbs up or a comment. If you have any questions, like I mentioned earlier, if you're interested in going deeper in PCG, specifically with me or other environment art topics, check out Aziel Art Academy. It's really a great resource for you, where I work directly with you on the things that you're learning about, making you custom tutorials and helping you along the way, as well as giving you access to all my backlog of courses and training content. If you're tired of scrolling through endless YouTube tutorials and things like that, this is a great resource for you. Otherwise, I will see you in the next one.